I understand this is probably really confusing what I'm trying to say here. I mean, there is kind of a general formula going on, which is on the next slide. But again, I'm just trying to illustrate through the calculation here why you want to replace x by x over 2. You know, when x is 6 years later, it's only gonna have increased in value, you know, by 12% 3 times. So 6 over 2, we get 3. But this is really the more general, how do I say, general method, so to say. If x is in years and you have exponential growth or decay, okay, and you know you have r, which is your constant percent rate, but if it's happening every m years, where again x is in years, you replace x by x divided by m. That's what I'm trying to say here. Right? Over here, it was every 2 years. So m would be 2 and r would be 12. And I guess a would be 9. But that's really what's happening here. So every m years, not every year, but every m years, every 2 years, 3 years, whatever, you replace x here in the exponent by x divided by m. Now, what could also happen is, I'm not sure we'll see it today, you could also have exponential growth or decay. But what can happen is you'll have that growth or decay n times per year. So it will happen n times per year. You're like 2 times in a year, 3 times in a year, 4 times in a year. And what will happen is the exponent then will be replaced by n times x. So if it's n times in a year, x is replaced by n times x. Okay. Again, obviously, you know, this is why I made the slide, so to help you remember. I know this is not easy to, it may not be easy to see. I am trying to illustrate through the calculations why this is true. I mean, hopefully I was successful, but I think we should probably stop here since we have 15 seconds left. All right.